大家有没有遇过，当前一个人留下来的程式码像本天书一样，看也看不懂，改也改不动，但跑起来哦，却又健步如飞的经验？今天我们很开心邀请到现任 Facebook 的软体工程师曾冠玉来教我们如何避免写出这样难懂、难读又难维护的程式。 不仅可以改善自己的程式品质，也适用于 code review 时给别人的建议。这样利人利己的撇步，赶快学起来！让我们欢迎曾冠玉。
Thanks for the introduction of the host. It's my pleasure to be here. And good morning, everyone. So today I'm going to talk about how to write quality code in Java. And using Android as an example. And before jumping to the topic, I want to talk about why I want to mention this topic. And the reason is that if you have ever worked on any code people give you, you might find some parts of it which look really ugly, not maintainable, not readable, and it's really hard to modify. But it just works really well. Like you can, whenever you add anything to it, it breaks. But whenever you try to replace it with something else, some other edge cases are not covered anymore. And this code is more like a unbeatable sheds. You have to, it's like it has been patched multiple times, so it works really well. And today's topic is to hopefully help people avoid writing such code, and then in the future, to make your code more structured. Cool. And before I mention any principles I'm going to talk about, I want to have a disclaimer here. Is what I'm saying may not always be true. It's always case by case, and so feel free to disagree with me if you have other ideas. Just try to come up with your reason why you disagree, and so that's always a very good discussion to have. Cool. So what is quality code? A simple rule of thumb to measure the quality of the code is to measure how long it takes to review the code. So if you have code review culture in your company, then you would notice that sometimes it takes really long to review someone's code, and usually that's because it's either very long or very complex. And so that also means that the quality of the code is not too good. So quality code has multiple features. The first four is simple. It needs to be readable, maintainable, reliable, and performant. I want to talk about the fifth property is reasonable. A reasonable code has very simple logic, and its logic is simple, easy to reason about. And so let me give you an example of reasonable code. So the reasonable code is easy to reason about, and let me come back to this later. A scalable code means the code leaves some room for future improvement. And a counterexample of scalable code is that if in Android you use View.getParent, sometimes when you move the view from one view hierarchy to another view hierarchy, then your code just breaks very easily. And that's one counterexample of non-scalable code. Or if you typecast context to activity, then that's also not a scalable code, because the context could be application or services. So you want to prevent writing scalable code too. You want to prevent writing non-scalable code. You want to leave some room for your code for future improvement. And a quality code is also consistent and flow-proof. Yeah. And so for a reasonable code, it's easy to reason about. And for example, for some variable, you know the variable is gonna be some certain value at any execution point of the time. For example, if your variable is defined as final, or if your variable is immutable, then your variable won't change, and so it's easy to reason your code. Cool. So before talk about how to write quality code, I want to mention there are 3 phases for a programmer to write quality code. The first phase is I call it see the mountain as a mountain. So 见山是山, which means a phase 1 programmer usually writes what he writes is what he sees. Whenever the UI looks this way, the phase 1 programmer will write the code that way, and it's usually very verbose, and it's usually long and has lots of copy paste, have lots of duplication. But the good part is it's readable, because what he sees is what he writes. There's no abstraction. So, and usually a phase 1 programmer only knows one way to get to the top of the mountain. So he just directly uses a single way to go to the top, to finish the spec. And as phase 1 programmer learns more and more, he starts to learn design patterns, use inheritance, polymorphism. And so he starts to see the mountain now as the mountain. He starts to abstract the code so that it's flexible. And he starts to, he basically would cover the mountain with the cloud because he want the code to be very flexible and then sometimes it's just overcomplicated. So as phase 2 programmer learn more and more, he see the mountain as the mountain again. He is able to use his experience, and he try to apply the principles of the design patterns case by case. Sometimes he would even intentionally try to duplicate the code just because, for example, the code is gonna be diverted at some point. At that point, it's even better to duplicate the code. So following strictly no code duplication may not always be the best idea. And let me give you an example on like the phase 1 programmer's code. Let's say you're building a shopping cart app, and you have a buy button, and you want to, when you click on the buy button, you show the unclear listener. And you show the dialog in the unclear listener. And so this is written probably by phase 1 programmer. It's very clear what he writes is what he sees, but it's not very flexible because you could end up have 20,000 lines in one class. Also, this alert dialog is not aware of the activity cycle. It's not aware of the activity life cycle of the activity or the fragment. So sometimes you could crash in some weird cases. So a phase 2 programmer would come in and say, let's model it as a state machine transition. It transitions from browsing state to checkout state, and then when the unclear listener happens, you just issue a buy button click event, and you have a state machine subscriber that subscribe to the state transition, and it transitions from browsing to checkout. And at that moment, it calls the callback, and the callback does the real work to show the dialog. And it's very convoluted and it's very abstracted. It might be really flexible, but it's not very readable. A new person in the team who comes in could potentially find it really hard to know what this buy button do. So phase 3 programmer would think it's too unreadable. So instead of using a delegate, a callback that only have the name on buy button click, and it doesn't describe what it does, it uses something called environment, which is similar to a callback, but it names what it does. So it names it show confirm dialog. So if you look at the first block of the code, if you look at the first block, the show inside the unclear listener, you call environment.show confirm dialog. So you know it's gonna show a confirm dialog with some title. And you don't need to know how to handle the life cycle of the dialog because it's handled already by the environment. And you can implement the environment later. But at least when you're reading the code, it's readable. And it's also flexible. The code won't actually won't stay in one class. It can be split into multiple classes. Cool. So if there's one rule to write quality code, then that is simplicity. A simple code is for sure easy to read, and a simple code is usually easy to modify too. But simplicity needs deliberation. You have to intentionally make your code really simple. Otherwise, the trend of the code, the entropy of the code usually grows whenever you start to add things into it or add people into your projects. So you have to really intentionally make your code simple to be able to make it readable and scalable. And so let me show you an example. So is this code clear to you? So let's say you are still building a shopping cart app, and you want to compute a total discount. You want to handle discount A and discount B. And this code is written this way, and you actually, by looking at the code, you don't know exactly what it does, what the total discount would be. But if you rewrite it into a right-hand side, you define total discount to be final, and if it's discount A, total discount is 20. If discount B, total discount is 10, otherwise 0. The left-hand side, right-hand side, the code in both sides, their logic are the same, but right-hand side is much more readable. And that brings us to the first principle I want to talk about is immutability. You want to have as many immutable variables as possible. Use final as much as possible, because there is a good property of a final variable, which is it's only assigned once. And when it's only assigned once, it's really easy to know its value at any point of the time of the execution. And also, you want to express something with single equation, so that functionally computes the result, so it's easy to know what the value is, because it's stateless. And also, if you are passing the data around from one class to another class, the best case you want to have is actually to have an immutable object, because you know the value is not going to change at any moment of the time. So you can use it without worrying about anything. So that's the first principle. And let's look at another code example. In this code example, I'll give you 10 seconds to read it and think about what's the problem with this code. So it should be a simple code. It has a setter, and it's double-click enable. So there's a problem with this code. It has a variable called is double-click enable, and there's a function called is double-click enable too. And which one should I trust when I see this code? And this code, for sure, it wasn't written this way in the first place. It must be written with a simple setter and simple getter, and somebody comes in and modify the code and add its current user into it, because it fits the need. But this is not actually a good code, because you don't want to have a confusing, you don't want to confuse people. And that's another principle I want to talk about. You want to have you want to use POJO function, a plain old Java object, as much as possible. And a POJO object is defined by, like, you have only simple setter and simple getter, and there's no magic inside in the objects. You don't have any side effect in the objects. And so a counterexample of a POJO object is if you have a listener inside your data, and then when you set the data, you will notify the listener, then it's not a POJO object. And when you try to manipulate these objects, sometimes it's painful, because you will just call the listener, and the listener sometimes will even cause memory leak because you hold on to the listener too long. And the third principle is to write one tiny class that does exactly the right thing. So imagine you're building, imagine you're looking for a library. Let's say you need to have a LRU cache in disk. What's the best case you can find in the GitHub? The best case would be you find only one class, and it's tiny. It's probably less than 2,000 lines, and it has very simple interface. It has an insert function, a constructor, a read function to read the cache, and that's it. And there's no external dependency of this class. It doesn't depend on anything else. So that's the best case you could find. And because you can just download the file, put it into your projects, and you can start using it. And if that's the best case you can find when you want to use a library, why don't you write your code to be a one tiny class so that it can be widely adopted, and you can even open source it for your company. So there's exactly such thing exists. It's the disk LRU cache written by Jack Watson. Jack Watson, who is a very famous person in Android world. And this is his GitHub for disk LRU cache. He has 3 classes, so it's not one tiny class, but it's close. And these 3 classes can even be merged into one class. And he has 3,000 stars in his GitHub for simple disk LRU cache. So try to write your code to be one tiny class that does mostly the real code and have very little boilerplate and have simple interface so it's easy for people in your company to reuse the code. And the next principle is to have single source of truth. Let's say you are building again a shopping cart app, and you have a you have a list of products, and there's a quantity there, and there's an edit button. So you have 2 activities. One is shopping cart activity. The other is product details activity. When you click on the edit button, it will show the product details activity, and you can modify the quantity there. And so it will be more like this. It will be more like this video. I'll show you. Okay, so it's playing the video. You click on the edit button. You adjust the quantity. And when you click on back, you want the quantity to reflect on the first activity. And when you click on it again, reduce it, background the app, foreground the app, kill the app even, or even uninstall the app. You want the quantity to stick around. And to be able to achieve that without any inconsistency issue, you want to have single source of truth. So there are 2 ways to implement this. One way is use start activity for results and use activity results to pass the quantity back. But that means you have multiple copies of the data, and they can easily get out of sync. Another way is using a memory cache, like this graph here. The green parts, there's a repository that's the single source of truth. Whenever you need the data, you try to talk to your memory cache, and the memory cache is not only providing a single source of truth, it also is syncing the data into the disk, syncing the data into your web server. So the data can even persist across app restarts, and the data can be persist across even multiple devices. And this is the next principle I want to talk about. If you have ever been to IKEA, you might find it's really easy to go from the entrance to the exit. And why is that? Because there's only a single path to go from the entrance to the exit, and it can cover almost all the furniture sections too. So that's a good property. You can just blindly follow the directions, and it takes you to the exit. And you want your code to perform this way too. You want to have a single way of doing things. So you don't want to have two functions that do similar things and that are slightly different, because whenever a new person in the team wants to use it, it's confusing to him. You don't know he or she doesn't know which function to call. You want to have a single function or a single way of doing the same thing, and make the function powerful, so you can always just allow people to call that function. And so, good. So let's say you're building a video upload flow to upload the video to the web server. And let's say you have 5 places that need to upload the video. If you have 5 flows to upload the video separately, then it's gonna be a nightmare, because whenever there's a 6th place that needs to be added, he either writes a new one, or he doesn't know which file of this we don't know which file of this we should call. And also, if you have 5 video upload flow, when you want to optimize it, you have to optimize it in 5 places. And that's not very efficient. If you have a single way of doing things, then you have one optimization. Then one optimization could benefit all call sites. Also, single way of doing things also means that try to have a straight line control flow. So let's use the video upload flow as example. Let's say there are 3 steps. One is render step, another is upload step, and config step. In each of the steps, you look at the left-hand side graph. In each of the steps, there might be some branching that could happen, but you want it to merge back into a single point because that will control the divergence of your control flow. If you let it diverge, then it would look like the right-hand side. The right-hand side would be the control flow with like a tree, and the control flow grows exponentially. So think about if you want to add performance logging into in your video upload flow. The left-hand side is really easy. You start the timer once. You end the timer once. And for the right-hand side, if you need to add performance logging, good luck with that. You have to start the timer multiple times and end the timer multiple times, and hopefully they are still called in pairs. So that's the good part of having single way of doing things. Another principle to write quality code is to use vanilla library or vanilla API as much as possible. And why is that? Because everyone knows what it means and everyone knows its implication. So take the MOPCON app as example. If you build a MOPCON-based activity for all the activities you use in the MOPCON, then you start to have this customized activity in your code, and a new person who comes into the team doesn't know what this activity is doing, and it can even change the behavior of what you think of an activity. An activity in Android usually calls on create first and on destroy, and it will always be called by on destroy when the activity is destroyed. Maybe MOPCON-based activity doesn't do that, or doesn't call it in pair, try to finish and return beforehand. So then the change the implication, and when people work on such code, it's really hard to work on it. So try to call the vanilla library, or you can call it built-in library as much as possible. And if you use any third-party library, you download any third-party library such as Android support library, try not to modify any code in the Android support library because it's really hard. First, you change its behavior if you modify it, and so we will have the same problem like I mentioned before. And secondly, if you modify it when there's a new version coming out, it's not easy to upgrade your support library, and you're stuck with the very old version of support library, and usually you don't get the free bug fixes, you don't get the free functionality upgrade too. So it's not really scalable to modify the third-party library. So if you really need to add some functionality on top of third-party library, try to write a wrapper around it, but try not to change it at all. And the next principle I want to talk about for writing quality code is to have a good variable naming. And start with some simple thing first. If you have some variable that has a major unit, suffix it with the major unit. For example, if you have time, suffix it with a milliseconds or microseconds. If you have distance, suffix it with meters or pixels, so people understand what the major unit is. And I've been bitten by wrong timestamp a lot. Like I thought it's milliseconds and it's actually microseconds. And if you have worked on some projects, you probably will feel the same way. Also, avoid misleading name. and trying to define a very accurate name. For example, if you have a function called getTotal, and inside the getTotal function, you try to update the total value you try to update the total value, try to update the member variable. And that is a very confusing name because you call it getTotal, you didn't tell me it's updating the total. So people would call it multiple times and figure out later the state of the object change. So if you are updating the total inside the function, then just call it updates and getTotal. Then at least it's clear. People will call it with some concern in mind. Also, don't have two functions that have similar names. For example, I see many cases you have setData and setData internal. And this is, again, the same thing. You have two functions with similar name, and I don't know which one I should call and what's the differences. I have to read into the code to see the differences. And so in this case, you could just call it setData that only sets the data, and you call setData and notify change that sets the data as well as notify the change. So it's very clear what this function does. You mentioned all the side effects this function is gonna have. And the next principle is to have separation of concerns when you are writing code. And this should be very familiar with people. So people know, oh, they have to put different write different logic into different classes so we can achieve separation of concerns. But what I usually see, the first point I want to mention is don't do fake decoupling. Because I've seen many code, people try to break down the classes, and they just break it down, but these two classes, the classes they break down into are still dependent on each other a lot. And it even makes the code looks worse. Because if every logic is in one class, at least you know what's gonna happen. Yeah, at least you know what's gonna happen. And in one class, it's very clear. So let me give you an example. So if you have two controllers, they're trying to control the same data, usually that's a smell for fake decoupling. And a more concrete example would be if you have two controllers that's trying to control the visibility of the same view. And so one controller would show and hide in one situation, another controller would show and hide in another situation, and they don't know each other too well because they are in different classes. And so you would end up having inconsistent states in your code, in your code and in the UI too. People will just somehow is able to, if the people try to show and hide the view multiple times, you could potentially get into an inconsistent state. So don't do fake decoupling would have good separation of concern. And another way to achieve separation of concerns is to separate the core functionality from the product basis logic. And try to think about a way that when you write the core functionality, nobody needs to change your code to be able to add product logic. So think about you are writing Chrome browser, and people are just writing plugins. And in this case, you can have a good separation of concern because you write your core functionality, and people don't need to come in and change your code, and they can already add their business logic into it. Another example would be if your app have a newsfeed, and the newsfeed has multiple way of showing the post. You want the newsfeed infrastructure to stay unchanged. People who add a new type of post doesn't need to come in to modify your newsfeed. Doesn't need to come in to modify your infrastructure code. Also, try to use different decision variable if the decision is independent. So if you have, I've seen code that looks like this. If background color is green, show the $sign. And why is background color related to whether we show the $sign or not? It turns out it could be you have two screens. One is blue, they don't have the $sign, and one is green, that has a $sign. So people will just write the code, oh, he knows background color is green, so he's not gonna show the $sign. But actually, these two are separate decisions. So just split them. And you just split them into two variables. You control the background color separately from the dollar sign. And you define a theme A that decide the first set of variable. You have theme B that define the second set of the variable. So that would be a good separation of concerns. And another separation of concerns example would be to have the model Viewmodel Architecture. I find it really useful to have either MVC or MVCC, MVVC. So model Viewmodel Architecture would be you have the green part is the model which holds onto the single source of truth. And you have activity and fragment, you use it as a controller, and then the controller reads the data, populates the view model, and the view model decides how the view should look. So then, in this case, you separate the concerns. And I want to show you another code example. This will be another principle. Let's say you have a drawable called circle, and you have another drawable called rectangle. And circle can draw circle, obviously, and rectangle can draw rectangle, obviously. What if you want to draw circle inside rectangle? Which class should you extend, right? Java has this restriction of the single inheritance, but it's not really powerful because you cannot extend, you cannot have two parents. And so the way to think about it is you actually want to prefer composition over inheritance. So instead of trying to inherit anything, convert the superclass into your weapon class. You have the circle class as your weapon, you have the rectangle class as your weapon, and you use circle.draw or rectangle.draw to be able to draw the circle inside the rectangle. So you don't need to extend from either circle or rectangle. So that's basically the next principle I want to talk about is to prefer composition over inheritance. And the essence of it is basically to convert superclass into weapon classes and hold on to them and use them instead of trying to inherit them. And because there's some problem with inheritance, the problem with inheritance is children try to know too much about its parents, and the parents try to know too much about its children. I won't go into detail here, but you could look up online on why inheritance has some issue. And so using composition is much more powerful. The last principle I want to talk about is to have React way of thinking. When React.js was first rolled out, I was amazed on how easy to write UI functionally. So there are two concepts in React. You split the system into UI. You split the system into UI and state. And state serves as single source of truth. And state itself decides how the UI should look. The UI itself doesn't decide how itself should look. And the UI provides a way for user to interact. So when user interact with the UI don't change its value directly. The UI comes back to change the state, and the state, since it's changed, it will reflect again onto the UI and decide how the UI should look. And let me give you an example. Let's say you want to show a discount icon when total cost is larger than 200, and when you enter the coupon code discount A in your shopping cart app. And so the total cost is one of the states. The coupon code is another state in this model. And user can easily change the total cost, and user can easily change the coupon code. And when the condition is right, then the discount icon will be visible automatically. So that's the power of React way of thinking. You don't need to have visibility of the discount icon as a state. It can be computed functionally. And the least state you have in the code, the easy to reason about the code. So that's React way of thinking. You want to have a single source of truth and let the state decide how the UI should look. Cool. So having said all this, So I've mentioned about 10 principles to write quality code. And it's actually more like playing Tai Chi. You have to blend the concepts, blend the principles, and use the principle wisely and case by case. You want to, sometimes you even want to forget some principles so that you can use them wisely. So it's more like a Tai Chi Chuan. And so the one thing you need to remember is simplicity. Trying to make your code simple is the way to write quality code. So that concludes my presentation. So I think I can take some questions now.
你好，就是在最一开始的时候，我记得你有提到，有时候你们会故意的把某一些 code 让它变得是重复的。对，那我想知道有没有什么判断的准则，是你什么会做这样的选择
？So I'll answer it in English. So the question is, I mentioned that sometimes we would intentionally duplicate the code, and the audience is asking why, what's the principle to decide when to duplicate the code, and so this is actually very case by case. I think the principle I did mention it a little bit is sometimes you know the code is gonna divert, and that's the time you duplicate the code, or when you put the code together, there are too many if-else inside the code. If you start to see too many if-else inside the code, that's a code smell, and the code will actually be really unreadable if you letting it grow and grow, and so you want to find a good point to slice the code into two parts. For example, if you are building two apps, and two apps looks very similar, and so the first time, so let's say you already have app A, and you are building a app B that has almost the same functionality as app A. So you start from reusing most of the components. But when you start to see, oh, I want to look very different in this screen, you want to look very different in some activity or in some fragment, then that's the time you probably start to say, okay, these two apps don't need to share all the components. We should extract the common components out and keep the differences in separate app. So that's the principle to follow. And it's actually case by case, so it does require some experience to figure this out. Yeah.
我想请教，就是如果说今天我写的 code 是 quality 好的 code， 就是 simple 的 code， 那是不是表示它也容易测试？还是说其实有时候有些simple 的 code 它反而不容易测试，你必须为了测試而把 code 變得比較複雜一些？
That's a good question. So the question is like, is simple code also testable? So I think simple code does suffer a little bit from not that testable, because if you want to make things very testable, it will be you need to abstract some concepts, and well, I think it's not like totally against each other. You can still have testable code that's simple, but you can also have some simple code where you don't care about the testability. And so I would say you need to make your own judgment on this part of the code, whether this part of the code is very risky. If that's the case, then you want to write the code to be a little bit more flexible, but try as much as possible to keep it simple. But if you are writing just some UI and then it's only show once, and you might as well make it really simple, and you don't even need to test it, because I also have some opinion on like testing everything. I feel like we should we should test only the things we care about and leave other time. For the UI, it's really hard to test. It's sometimes best to just use the screenshot test or use the end-to-end test. Yeah. Thanks.
Have you used enjoy data binding library, and will you write complex logic in XML file? Thanks.
Okay. So the question is, will I use data binding library that's proposed by Google? I'm still skeptical of it because so I actually hear some talk about the inventor of data binding library, and the author of that says Google tried to propose something that applies to probably 80% of the case, but in the end it won't be flexible enough. So data binding will suffer from the same issue. If you have lots of animation in your code, I think it would be really hard to actually use data binding library to achieve your goal. Or if you have to mutate your data a lot, then it's also really hard to use data binding library. It's good to use when you have lots of data that don't change. For example, if you are showing just the conference schedule that won't change, then that might be easy. I think they later proposed another thing called architecture components, which I think is more flexible, much more flexible than data binding library. So I think I would still evaluate architecture components, but data binding library, I haven't tried it. I've read it, but I think it has some limitation. That's my take of it. Yeah. Cool. So thanks everyone for the talk.
那我们掌声谢谢曾冠玉带来的精彩演讲。